Welcome, students. Let's continue about our chapter Stars and the Solar System. As I told you in the previous lecture, that there are various celestial objects which are present in the night sky, which we can easily see in the night sky, like stars, planets, moons, meteors. So, let's first discuss about stars. There are billions of stars in the sky. In fact, on a clear, moonless night, we can see about 3,000 stars with naked eye. Even many more stars can be seen then with the help of a telescope. Now, there's an important characteristic of stars, that is stars twinkle at night. Actually, stars appear to twinkle in the sky. That is, their light increases and decreases continuously. But the twinkling of stars, it's an illusion, it's a false show that is caused by the disturbance of stars' light by Earth's atmosphere. That as stars' light have to pass through the Earth's atmosphere, and because of the refraction of starlight, we its stars appear to twinkle. Okay, stars are present even during day, but are not visible due to glare of sun. See, during daytime we can see only the sun in the sky. Why? Because of the glare of sunlight, rest of the objects can't be seen. It means because of the glare of sunlight, because of the brightness of sunlight, we cannot see any other celestial object in the sky during the day. But as soon as the sun sets in the evening and it becomes dark, we can see many celestial objects in the sky. In fact, we can see stars as well in the night sky. Stars are like huge and extremely hot balls of fire. Basically, these are the celestial objects that are extremely hot. Stars are made of hydrogen and helium. Stars consist mostly of hydrogen gas. And as stars have their own light. Now the question arises, where does this light comes from? So the heat and light of stars is produced by the nuclear fusion reactions that are taking place inside the stars all the time. In these fusion reactions, hydrogen that is present inside the stars gets converted into helium, and with this conversion, tremendous amount of heat and light is produced. So that is why the stars are emitting heat and light continuously. So stars have their own light. They are the luminous objects because they emit their own light, and that heat comes because of the nuclear fusion reactions that are happening inside the nucleus of the stars. Now, if you look at this picture, see this boy here and the girl here. This boy appears big in size and this girl appears small in size. What is the reason behind the difference in their sizes? Actually, this boy is near to us. That is why this boy appears big in size. And this girl is far from us and it appears small in size. So, the same object looks smaller if far from us. And the same thing happens in case of stars. Stars are very, very large objects having the shape of a ball. Stars are extremely huge but look small as they are extremely far from us. If you look at the night sky, you can see the tiny objects as stars, and you can see that moon appears big in size. But stars are much bigger than the moon. In fact, some stars are even bigger than the sun. But stars appear to be small because they are very, very far from us, because of their extremely large distance from the earth. Now, if we talk about sun is also a star. And again, the same thing, many other stars in the universe are bigger and brighter than sun. but sun appears bigger and brighter as sun is much closer to us as compared to the other stars. See, in reality, sun is also a star, but we do not call the sun as star. But reality is that sun is also a star, and sun is a star which is nearest to the earth, which is closest star to the earth, and sun looks much bigger and brighter than the stars because sun is much nearer to us than any other star. Although many other stars are bigger and brighter than the sun, but they look small and faint because they are very far from earth as compared to sun. And we can see the stars only at night. As I told you, they are present even during the daytime, but we cannot see them during daytime because of the bright light of the sun. In fact, there are 10,000 billion stars in the universe, and sun, that is also a star. The next nearest star to earth is Proxima Centauri. Now let's talk about the movement of sun and the other stars. If you look at this picture carefully, suppose this is a man and he's traveling in a bus or in a train, and this bus or train is moving at a very high speed. Now, what happens when this person looks outside the window? It seems as if the objects are also moving. Suppose the direction of passenger's motion is this, that is from right to left. But when this person looks outside the window, it seems that the objects are moving at very high speed in the opposite direction. That means from left to right. It might have happened to you guys also whenever you are traveling in a bus or train and the bus is moving at very high speed. It might happen, it seems as if the things outside are moving in the opposite direction. Similar thing happens here. We know that sun rises up in the east in the morning and then travels in the sky the whole day and then sets in the west in the evening. So the sun appears to move in the sky from east to west direction. Same is the case with all the other stars. It appears that stars, sun, they are moving from east to west in the sky. But this is the apparent motion of stars. That means it appears as if stars, sun is moving from east to west. But what is the reason behind this? Why we why this apparent motion happens? See, you guys know that I told you that when we move in one direction, other stationary objects appear to move in opposite direction. Now what happens? We all know that Earth rotates on its own axis. So basically Earth rotates on its axis from west to east. So what happens when earth is rotating? Basically we are present in the earth, we are on the earth, right? When earth rotates from west to east, the rest of the objects, stationary sun, stars, they seem to move in the opposite direction. That means it appears that the sun and stars are moving from east to west. So this is the apparent motion of stars from east to west, and it is due to the rotation of earth from west to east on its axis. So here you can see this is our earth, okay, and this earth revolves around the sun, and also earth rotates on its own axis, right? Now when earth rotates like this, as you can see here in this arrow, when earth rotates like this, that means when earth rotates from west to east, what happens? It seems that the rest of the objects, that means that's the sun, it seems that sun is moving in this direction. Earth moves like this from west to east. So it seems that sun and rest of the stars, they are moving in the opposite direction. That means from east to west. So whenever earth moves, rotates from west to east, stars and the sky appear to move in the opposite direction. That means they appear to move from east to west. Now, there's one star which does not appear to move in the sky. It's called pole star or Dhruvatara. This star, it appears stationary from the earth. It means that this pole star always remains in the same position in the sky. Though all other stars appear to move from east to west, but this pole star remains fixed at the same place in the sky and in north direction. It means this is visible only in the northern hemisphere, not visible from southern hemisphere. Okay? Now, what is the reason behind this? Why this pole star appears to be stationary and does not change its position with time? See, the reason for this is that pole star lies on the axis of rotation of the earth. That means pole this see, suppose this is earth and earth is spinning at its own axis, and say this is the axis of rotation of earth. It means earth is spinning at this axis. Now this pole star, it's lying here at this axis of rotation, and this axis of rotation, it's fixed in space, it doesn't change with time. And when this axis doesn't change, rest of the objects changes. When earth is moving, it appears that stars are also moving, because stars are not present at this fixed axis. So this pole star lies on this fixed axis, and because this axis is fixed, so it appears that pole star is not moving, it doesn't change its position. So that is why pole star remains fixed, it remains stationary, and all other stars appears to revolve, appears to move. Okay? And uh, it may be clear to you by this example. This is an activity, you can do it. Now, this activity actually, the fact that pole star does not appear to move and remains stationary in the sky can be understood by this experiment, by performing this activity. You can take an umbrella and open it. Then make about small stars, almost 1, 2, 3, 4, 5, 6, 7, 8, 9. Take 9 or 10 small stars, make them out of paper, and then paste one star at the top position of the central rod. You can see the central rod. Place one star at the top position of the central rod of umbrella, and place other stars at different places at the edges on this umbrella cloth near the end of the spokes, sorry. Now rotate the umbrella by holding its central rod in your hand. Now when you rotate this, you will observe that the paper stars are also rotating, because the paper stars are on the rotating umbrella. You will find that all the stars that are present, that are placed on the spokes, they will appear to move. But there is one star which doesn't appear to move. The star which doesn't appear to move is located here at the top end of central rod, which is rotated actually. So in this activity, the central rod of umbrella is like the axis of rotation of Earth, and the star fixed here at the top end is like the pole star. So basically, pole star appears stationary because it's present at the axis of rotation. Okay, and rest of the stars appear to move from east to west because Earth is rotating on its axis from west to east.